Okay, so for homework tonight, you are going to be watching this video and doing some problems in the packet. So we are going to start with the packet that was passed out on Tuesday. It's packet number 2, okay, and this is scientific notation. Okay, let's flip and let's turn to page, we are at 58, okay? And we are talking about scientific notation, okay? And if you look at these two numbers right here, those are actually written in what we call standard form, okay? Standard form. You probably have seen things that look like scientific notation before. So for example, this, if we wrote it as 1 times 10 to the negative 8, that would be what we call scientific notation, okay? That's scientific notation. And why do we use scientific notation? It's easier to write than standard form. Okay, and so that's why we use it. You're going to use scientific notation for very large, it's supposed to be an A, for very large and very small numbers. Okay, so we're going to use scientific notation when we see large and small numbers. Okay, so each of these numbers here is written in scientific notation. And you can see a few features of this if you look at both of them. And it says, what do you notice about the first number, the first factor? Well, this first number, there's one digit. Can you see that? You can see that here. There's one digit in front of the decimal place. Okay, there's one number in front of the decimal place. And what do the numbers have in common? Well, we have a times 10, right? There's something that's in common. They both have this 10. And what about the exponents? We can call them exponents or powers. It's going to be an integer. Okay? And if you have a positive exponent, it's when you have big numbers, okay? And as you can probably guess, when you have a negative exponent, that's when you have small, little, whatever you want to say, little numbers, okay? Let's flip the page. Okay, this is really important, okay? I'm going to circle this right here. You must know what makes a number a good number, meaning it is in scientific notation, okay? And we are going to have a couple things, okay? We're going to have this first number, which sometimes we call the coefficient, okay? The coefficient is this first number. There it's A, and it has to be greater than or equal to 1, but less than 10, okay? So it's going to be a single number with potentially a decimal point and other digits. But the key thing is that it's going to be less than 10 or greater than or equal to 1, okay? You're going to have a base of 10. That's always the case. You're always going to have a base of 10. It's going to be multiplied, and then you're going to have an exponent that's an integer, okay? So here we have the digits. We have the power. We have the 10, and then we have an exponent, okay? So those are the things to know. Let's go ahead and let's talk about, so the coefficient is the number in front, we'll say, okay, the number in front. Then we have digits here. You can see up there all the digits. And then the power is going to be an integer. Let's see if I can spell, okay? Okay, identifying numbers written in scientific notation. Tell whether the number is properly written in scientific notation. Explain your answer, okay? So we have 5 9/10 times 10 to the negative 6. Is that written in scientific notation? Well, it is, and we're going to have 3 things that we're going to write about it. We have a digit, or you can call it a coefficient, is between 1 and 10, okay? It's greater than or equal to 1, but less than 10, Okay, so that's one thing that we can check off. It's times 10, so that's good. So we can check that off. And our last thing is that is the integer, or we have an integer exponent, I should say. Okay, so those three things make it clear that yes, it is in scientific notation. Okay, let's flip over to 1b. Here we have 0.9 or 9/10 times 10 to the 8th. Okay, and what we see a big difference here, okay, is that this number right here is the problem. Okay, so it's going to be no. And that's because the digit or coefficient is not between 1 and 10. We can say, though, it does have times 10 and an integer exponent. But unfortunately, that digit here is not greater than or equal to 1 and less than 10. So it cannot be in scientific notation. Okay? Next, what do we have here? We have number 1C. Okay? 27.75 times 10 to the 12th. And again, this is no. It is not, and that's because, again, the digit, whoopsie, the digit is not between 1 and 10. Okay? We do know that it's times 10 and an integer exponent. But if any one fails, okay, then it is not written in scientific notation. Okay? Letter D, 1.35 or 1 3500ths times 10 to the negative 7th. And that is going to be a yes. Okay? We have a digit that is between 1 and 10. Okay, so that's good. Has a base of 10 or times 10. Okay, and it has an integer exponent. So all those features make it that yes, it is written in scientific notation. Okay, why don't you try 1E and F, and then pause it for a minute, try those, and then we'll flip back and look at those. Okay, you should have had time by now. Number 1, as you can see, this is a plus, and that is a problem. It must be a base of 10, and it must be multiplication, okay? So we're going to say no, not okay, should be times 10, okay? So that's a no. And 1F is also going to be a no, and that's because it's not times 10, so it's a no, okay? Because that has to be a 10, okay? Let's go ahead and let's flip the page. And we are actually close to being done. This is not going to be a very long video, okay? Converting numbers written in scientific notation into standard form. When converting from scientific notation to standard form, here are the things to remember. If the exponent is negative, okay, so if we have a negative exponent, okay, the number, let's cross that off, we don't need that. The number is small. So we're going to move decimal point to the left. Okay, so if the number is small, the exponent is going to be negative, and we're going to move the decimal point to the left. If the exponent is positive, then that number is big, and we're going to move the decimal point to the right. Okay? So let's write some of these numbers in standard form. Okay, we have 4 and 23 thousandths, hundredths, 4 and 23 hundredths times 10 to the 5th, okay? So we know that we have a positive exponent, okay? So we're going to go to the right 5 places, okay? So what I do is I do it like this. I write the number out and I go 1, 2, 3, 4, 5, and I fill in my zeros. So that is going to be 423,000. Okay? 2b. We have a exponent that is negative, so we are going to go left by 4 places. Okay? So I always start, I write my decimal, and then I'm going to go to the left. So I'm going to go 1, 2, 3, 4, and I fill in my zeros. Okay, so that's going to be 0.0007003. Okay, we can see right away that it's much easier and cleaner to write it in standard form where you can actually see it nicely than to write it in standard form, or scientific notation than standard form. Okay, 2c, 3.22 times 10 to the negative fourth. We're going to move this left 4 places. Okay, and we are going to do 3.22, and we're going to move it left 1, 2, 3, 4. We fill in 3 zeros. It does not mean that there's 4 zeros necessarily. It means that we're going to move it 4 places. Okay, so we have 0.000322. Again, that means how many places we're going to move it, not zeros. Okay? 2D, 7.93 times 10 to the fifth. Here we're going to move it right 5 places. Okay? So I'm going to start here with 7.93, and I'm going to move it 1, 2, 3, 4, 5, which means I have to fill in 3 zeros. So I have 793,000. Okay? I should be circling these so you can actually make sure they're clear. Okay? Then we're going to look at 2e. We're in the home stretch here. 8.653 times 10 to the 8th. We are going to go ahead and we're going to move that right, and we're going to move it 8 places. Okay? I have 8.653, and we're going to go 1, 2, 3, 4, 5, 6, 7, 8. So we have quite a few zeros we have to fill in. Okay, so that's going to be 8,653. We have 1, 2, 3, 4, 5 zeros. And we're going to get, there we go. Okay? Again, we're talking about the number of places. On 2F, we're going to go left 6 places. Okay, so we're going to start with our 1.99, and we're going to go 1, 2, 3, 4, 5, 6, because we have a negative exponent. So I'm going to fill in a bunch of zeros here. And we have 0.0000199. Okay, is that right? Let's see. 5 zeros, 1, 2, 3, 4, 5. Perfect. Okay? And there's our answer in standard form. Okay? And finally, we have 2.36 times 10 to the negative 7. We're going to go 7 places to the left. And that's because we have this negative exponent here. So 2.36, and we're going to go 1, 2, 3, 4, 5, 6, 7. I'm going to fill in my zeros. Okay, and I have 0 point, and I have what? 1, 2, 3, 4, 5, 6. 2, 3, 6. Okay? So there's really not much to this. Okay, the last one we have a positive exponent, so we're going to move it right 3 places. 2.3654, and we're going to move it 1, 2, 3. So we get 2365.4. And that is all the notes for today. And you can go ahead and you can start on your homework.